So today we're going to be working on solving systems by graphing. So the one thing we need to remember most is when we're graphing, we do prefer things to be in slope-intercept form just because it's really quick and easy to go ahead and graph a line. So looking at the system we have here, we need to check that they're in slope-intercept form. Looking at this first equation here, x plus y equals -1, I can clearly see that it's not in slope-intercept form. How do I know? Well, I know slope-intercept form is y equals mx plus b, which means the y should be isolated. In this case, it's not. It appears to be in standard form since both variables are on the same side. So I'm going to go ahead and have to convert this into slope-intercept form. I need to isolate my y by getting rid of my x. So I get y equals -x minus 1. Now that it's in slope-intercept form, I can identify the slope as -1 because there is an imaginary 1 right in front of that x. And my y-intercept is the -1. So now I can go ahead and graph starting with my slope, my y-intercept at -1. And my slope is a -1, which means my line should be going down. Please keep that in mind. So I'm going to go ahead and graph down 1 to the right 1, down 1 to the right 1, and I'm going to go ahead and draw the line. Now the next one, again, I notice it is not in slope-intercept form. Both variables are on the same side. So I'm going to go ahead and isolate my y by adding x to both sides, leaving me with 2y equals x plus 4. Now I have to isolate my y by dividing off my coefficient, by dividing everything by 2, leaving me with y equals 1/2 x plus 2. Now it's in slope-intercept form, which is perfect. I'm going to go ahead and identify my slope as 1/2 and my y-intercept as +2. So I'm going to go ahead and graph starting with my y-intercept, which is 2. So I'm going to put my point at 2. Now my slope is +1/2, which should mean my line should be going up as I read it from left to right. I'm going to go up 1 over 2, up 1 over 2, and there is my line. So notice here I actually have an intersection. That point where both lines intersect is my solution. It's -2, 1. So the solution for this graph would be -2, 1. So let's go ahead and continue with some more examples. What about for this system, y equals -2 and x equals 4? In this case, we're not going to have to change anything into slope-intercept form. We're just going to go ahead and graph these lines. What I like to do is I like to at least list 3 coordinates where all of my y's are -2. So I chose 0, -2, 1, -2, and 2, -2. Since the function rule was y equals -2, all of my y values were -2, which is exactly what I'm supposed to do. I'm going to go ahead and graph those 3 points, and there is my line. So notice a y equals a value would result in a horizontal line. Now I'm going to go ahead and graph x equals 4. So here I'm going to do the same thing. I'm going to list 3 coordinate pairs where all the x values are 4. So I chose 4, 0, 4, -1, 4, 2. These points are perfect. Why? Because my function rule is x equals 4 and all my x values are 4, which is perfect. I'm going to go ahead and graph them and then draw my line. Perfect. Now I see that the intersection occurs right here. So my solution would be 4, -2. So notice graphing could be pretty useful if things are already in slope-intercept form or if the equations are pretty simple. So my solution would be 4, -2. Let's go on and try another one here. I'm going to again try to put things in slope-intercept form. I can see right here that's already in slope-intercept form, so I'm not going to have to change that equation at all. So I'm going to go ahead and identify that the slope is -1/2 and my y-intercept is +1. So go ahead and start graphing with your y-intercept at 1. Sorry, 1 is right here. My slope is a -1/2, which means the line should be going down as you read from left to right. So I'm going to go down 1, and in order for this line to go down, I'm going to go to the right over 2. Down 1 over 2. And that's my line. Now, looking at the second equation, it's not in slope-intercept form. It's actually in standard form. So I'm going to have to go ahead and manipulate this equation to turn it into slope-intercept form. I'm going to try to isolate my y by first getting rid of the x term, subtract it from both sides, leaving me with 2y equals negative x plus 6. Now I want to isolate my y variable, so I need to get rid of the coefficient by dividing everything by 2. And I get y equals negative 1/2 x plus 3. So now that it's in slope-intercept form, I'm going to go ahead and identify my slope as negative 1/2 and my y-intercept, which is a positive 3. So now I'm going to go ahead and graph, starting with the y-intercept at 3. My slope is a negative 1/2, therefore my line should be going down. I'm going to go down 1 over 2, down 1 over 2, and notice, hopefully you can see that these lines are both parallel. And the reason why they're parallel is because of the slope. Since they're moving at the same rate, these lines will never intersect because they're starting at different points. So in this case, since the two lines will never intersect, there is no solution. Okay, so continuing on, I'm going to show you the three possible outcomes. You can have one solution where the two lines intersect at one point. You can have no solution where the lines are parallel and they will never intersect. And you can have something called infinitely many solutions. And when will that occur? If you have one line and the second line is right on top of it. Okay, we call that lines coinciding with one another, and we call that infinitely many solutions. So let's look at another example. Here again, I'm checking to see, do I have it in slope-intercept form? In this case, I do. So I'm just going to go ahead and identify everything. My slope is 1/3. My y-intercept is 2. Then I'm going to go ahead and start plotting them, starting with my y-intercept, which is 2. My slope is a positive 1/3, so meaning my line should be going upwards when I read it from left to right. I'm going to go up 1 over 3, and then go ahead and graph. Now the second equation, it's not in slope-intercept form, so I'm going to have to manipulate the problem in order to do that. I'm going to try to isolate my y by first subtracting 2x from both sides, leaving me with the negative 6y equals negative 2x minus 12. Now in order to isolate my y, I'm going to have to get rid of my coefficient by dividing everything by negative 6, leaving me with y equals 1/3 x plus 2. Now, since it's in slope-intercept form, I can identify my slope as 1/3 and my y-intercept as positive 2. So I'm going to go ahead and graph, starting with my y-intercept, which is 2, so I'm starting right there. And then my slope is up 1 over 3, and clearly you can see that both of these lines coincide with one another. So basically, this is a solution, that is a solution, that is a solution, that is a solution, that is a solution, even in between. That is a solution. So we would say that there are infinitely many solutions. So we went over one of each type, one where there was one solution, one where there was no solution when the lines were parallel, and then one where there was infinitely many solutions because the lines coincided with one another. So hopefully this helps. If not, go ahead and leave some comments and I will make sure to answer any questions that you have. Thank you for watching and have a wonderful day. Thank you.